Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so now for this part, we will be discussing about definite integrals. Okay, in definite integrals is the part where you calculate the area under the graph or the volume generated by the graph. Okay, so now first let's look at about a few what we call this, a few things or principle in definite integrals. Okay, so let's say we have integration of 3 1 f(x) dx that is equal to 5 and integral of 8 3 f(x) dx that is equal to 10. Okay, we have these two integration of function. Okay, so now let's look at A. For part A, that is find integration of 3 3 d 3 3 fx dx. Okay, so since 3 3 fx dx so means the area under the graph under the line of x equal to 3. So when this happen, when 3 is equal to 3, so the area under the graph will be equal to 0. Okay, so for B, is find the integration of 1 3 fx dx. So our given example of integration is from 3 1 fx dx, but the equation 1 1 3 fx dx. So when this happen, what we need to do that it is equal to negative 3 1 fx dx. So our answer is equal to negative 5. So it means like it is the opposite of the integration of the function. Okay, for C is the integration of 3 1 4 fx dx. So this one is simple, that is just 4 5 and 20, because it already mentioned that integration of 3 1 fx dx is equal to 5. So the addition of 4 in the function means that our answer of the integration will be multiplied with the number of 4. Okay, for D, D is integration of 8 1 fx dx. So it is the same function, but now it covers from the x equal to 8 until x equal to 1. So it just means that integration of function 8 3 fx dx plus integration of function 3 1 fx dx. So it covers from 8 until 1. So our answer is just 10 plus 5 equal to 15. And our final identity is integration of 8 3 fx plus 5 dx. So this form of integration is just the same as 8 3 fx dx plus integration of 8 3 5 dx. So we already know the integration of 8 3 fx dx is equal to 10. So what we need to do is we have to integrate 5 dx. That will give us 5x 8 3. So our answer is equal to 10 plus 5. We substitute 8 with x minus 5 3. So our answer is 10 plus 40 minus 15 equal to 35. Okay, so for our first example, let's find the definite integrals of exponent 1 x plus 1 over x square dx. Okay, so this is just the same as integration of exponent 1 x over x square plus 1 over x square dx, so equal to integration exponent 1 over x plus x power negative 2 dx. So when integrated, 1 over x produce ln x, okay, minus 1 over x exponent 1. Okay, so now we substitute exponent and 1 into the equation. So we have now is ln exponent minus 1 over exponent minus ln 1 minus 1 over 1. So what we have here, ln exponent is equal to 1 minus 1 over exponent. So ln 1 is 0, so then we have plus 1. So what we do is 2 minus 1 over exponent. So that is our answer for the integration of the function. Alright, so our second example is integration of 3, 1, 2x ln x dx. So this kind of integration, what we need to do is we need to differentiate it by part. So what we need to let u equal to ln x, so du is equal to 1 over x dx. So then we have dv over dx, that is equal to 2x, so v is equal to 2 x square over 2 and just x square. So now we follow the equation of integration by parts, that is u v, so ln ln x and x square minus integration of x square du is 1 over x dx. So we have here x square ln x minus integration of x dx, so that is equal to x square ln x minus x square over 2 plus c. Okay, so now we have reached to this point. What we need to do is we have to, so now we substitute 3, 1, then we have 9 ln 3 minus 9 over 2 minus 1 ln 1 minus 1 over 2. So since ln 1 is equal to 0, so then we have right here 9 ln 3 minus 9 over 2 plus 1 over 2. So that is equal to 9 ln 3 minus 4, or we can also write it down as 5.89 unit square because it is an area. Okay, for number 3, example number 3 is the integration of exponent square, exponent 1 over x 2 plus x square dx. Okay, so this is a fraction with different multiplication at the denominator. So what we need to do is we have to do partial fraction, that the equation is equal to 1 over x 2 plus x square is equal to a over x plus bx plus c over x square plus 2. Okay, so 1 is equal to a x square plus 2 plus x bx plus c. Alright, so now we expand the bracket, so it becomes a x square plus 2a plus bx square plus cx. So now we let x equal to 0. So when x equal to 0, what left is 1 equal to 2a. So a is equal to 1 over 2. Alright, so now let's look at the coefficient of x square. So 1, so 0 is equal to a plus b. So a is already 1 over 2, so means b is negative 1 over 2. And coefficient of x, the only coefficient of x is cx, so c is equal to 0. Okay, now we resubstitute the equation of the integration, which is 1 over 2x minus x over 2x square plus 2 dx. So this is what we want to integrate. So we simplify this integration first. So it is 1 over x minus x over x square plus 2 dx. Alright, so we want to integrate this, but the fraction here first. We solve this first. Since the numerator is x and the denominator is x squared, it is kind integration of ln that we produce ln, right? So what we need to do is here is we need to add 2 at the numerator, because when we differentiate x squared, it gives us 2x. So in order to balance the 2x, we have to add 1 over 2. So from here we can integrate. So this one becomes ln x minus 1 over 2 ln x square plus 2 plus c. Alright, so now we have complete the integration. So now we have to add the value of x, which is exponent square and exponent. Okay, so now we substitute. We multiply the 1 over 2 into the equation. So that is 1 over 2 ln x minus 1 over 4 ln x square plus 2 exponent square exponent plus c. Alright, so now we substitute the exponent square and exponent into the equation. So it gives us 1 over 2 ln exponent square minus 1 over 4 ln exponent. So this is x square. So since this is x square, so we want to substitute it with exponent square, so it becomes exponent to the power of 4 plus 2. Sorry, this is the modulus minus 1 over 2 ln exponent minus 1 over 4 exponent square plus 2. Okay, so now we solve this equation. Okay, so since this one is 1 over 2 ln exponent square, so 1 over 2 ln exponent square is actually equal to ln exponent square 1 over 2. So when we solve this one, then we have ln exponent 2 over 2 that is equal to ln exponent. So ln exponent is equal to 1. So we write it down as 1. So 1 minus 1 over 4 ln exponent power 4 plus 2. Okay, so minus, so ln exponent is 1 minus 1 over 2 plus 1 over 4 exponent square plus 2. Okay, so now we have this 1 minus 1 over 2. So then we have 1 over 2. So since I forgot to write down ln right over here. So since this is ln, positive ln and a negative ln, what it means here is that it becomes 1 over 4 ln exponent square plus 2. A positive one will be the numerator of the component for ln, okay, not for the whole 1 over 4 ln. So the denominator is exponent power 4 plus 2. Okay, so if you didn't understand for this part, I recommend you to revise the properties for logarithm. So from that you will understand why does it becomes 1 over 4 ln exponent square plus 2 over exponent 4 plus 2. So that is our final answer.